Welcome pre-cal students to the review shootout video. I'm going to try to do an entire video just by whispering, and hopefully you'll be able to hear me. I hope this will work. My voice is really bad, so hopefully whispering will work. You'll have to turn the volume up very loudly, but I hope this will work. We're going to try this just one time and see how it goes, okay? Alright, number 79. I'm going to solve this exponential equation. So we have 8 to the x power equals 512. Now remember, students, our goal is to always write both sides with the same base when we can, okay? So we're going to try to do that. Now, students, what I did is I took my calculator and I experimented, okay? And I said to myself, okay, maybe I can write both sides with a base of 2. Maybe I can write both sides with a base of 8. So I took my calculator and I typed 8 times 8 times 8. And when I did that, I got 512. So I realized right away that I can write 512 with a base of 8. So 8 to the x equals 8 to the third power, okay? Like that. Now, cross off your like bases, set the exponents equal, and we are good. Your answer is x equals 3, okay? Alright, continuing on to the next problem. Okay, number 81, we have 6 to the x power equals 1 over 260. Now again, students, I'm going to try to write both sides with the same base. So what I'm going to do is take my calculator. I'm kind of curious. Maybe I can write 216 with a base of 6. Maybe I can. So I'm going to take my calculator. I'm going to type 6 times 6 times 6, and that gave me 216. So all that I'm trying to do, guys, is I'm trying to write both sides with the same base. So 216 is 6 to the third power. Okay? Now bring this up top, and when you do that, you'll be left over with 6 to the negative 3. Okay, there we go. So cross off your like bases, set these equal, and your answer is negative 3. Okay? Alright, moving on to number 83. Now this is called a logarithmic equation, okay? Logarithmic equation. And here's what you've been taught to do, alright? You've been taught to, when you have one logarithm on one side, to write the expression exponentially. So here we go. Now let me stop and say this, students. If there was a number here like a 3, you would first have to pick up the 3 and move it right here. Okay? Now, in this problem here, there is no number here, so we're good to go ahead and write this exponentially. So let's take this logarithmic equation and let's write it exponentially. Look how easy that is. X equals 7 to the 4. So with my calculator, I'm going to type in 7 arrow 4 equals 2,401. Now remember, students, whenever you solve a logarithmic equation, you need to take your answer and make sure that it works in the original problem. So let's go ahead and put 2,401 right here. And if we do that, we can see that we can definitely take the logarithm of 2,401. We can do that. So yes, this answer works. Now, if this had been a negative number, then you would not be able to take the logarithm of a negative number, okay? But that is not the case, so we can continue on. Okay, number 85. This is called an exponential equation. Now, guys, please notice there's no way we can write both sides with the same base. It's totally impossible. We have a base of e and a base of 12. So whenever you're solving a logarithmic equation, an exponential equation, and you want to write both sides with the same base, and you can't do that, then what you need to do is go ahead and look at the base of your unknown. In this case here, it's an e, so we're going to take log base e of both sides. Now, why did I choose base e? Because the base of my unknown was an e. So I'm going to take log base e of both sides, okay? So log base e of both sides, go ahead and bring this down. And here we go. Notice here your base matches your base. So all of this is gone, and you're left with your exponent. X equals natural log. Log base e is natural log of 12. So x equals natural log of 12, which would be 2.485. Rounded correctly, 2.4 0.85. Okay? All right, number 87. Here we go. Now notice here again, students, that I have an exponential equation, okay? Exponential equation. And so my goal is to write both sides with the same base. However, there's no way that I can do that. There's no way when I have a base e and a number over here that I can write both sides with the same base. It just can't be done. So here's what you want to do. You want to get the unknown and its base all by itself. So I'm going to divide both sides by 3. And I'm left with e to the negative 5x equals 44. Okay? Now here's what we do. The base of my unknown is e. So I'm going to take log base e of both sides. So we'll bring this down here. Bring this down over here. And now look on the left side, guys. Whenever your base matches your base, this is all gone and you're left with the exponent. So negative 5x equals, don't forget that log base e is natural log. Okay, now divide both sides by negative 5. And x equals the natural log of 44 divided by negative 5. So your answer would be, here we go, natural log of 44, enter, divided by negative 5, enter, and you will get negative 0.757. Rounded correctly, negative 0.757. Okay? All right, that was number 87. Let's go ahead and take a look now at number 89. Number 89, let me get a drink here real quick. And here we go, number 89. Okay, we have e to the x plus 13 equals 35. Now, first of all, whenever we have an unknown in the exponent, we call that an exponential equation. And we would love to write both sides with the same base, but there's no way we can do that when we have an e. What I'm going to do is I'm going to get the unknown and its base all by itself, okay? So bring the 13 over and make it negative 13. So now I'm left with e to the x equals 22. Now my base of my unknown is e, so I'm going to take log base e of both sides. Okay? Bring this down. Bring this down. Now when your base here matches your base here, everything is gone except your exponent. So your x would go right here. Log base e is natural log of 22. So there's your answer. Grab your calculator and type in log of 22 and you will get 3.091. 3.091. There we go. Moving on to number 91. Okay, number 91. Negative 4, 5 to the x power equals negative 68. Now first of all, I would like nothing more than to write both sides with the same base, okay? But before I do that, I better get the base of my unknown by itself. Here's my unknown, and here's my base right here, okay? So to get them isolated, I'm going to divide both sides by a negative 4. Okay, so when I do that, I'm left with 5 to the x equals positive 17. Now, students, there is no way that I can write both sides of this equation with the same base. There's no way. Okay, so the base of my unknown is 5. So I'm going to take a log base 5 of both sides. Okay, log base 5 of both sides. Now watch carefully. Whenever your base matches your base, everything is gone except your exponent. Okay, and over here we have log of 17, enter, divided by log of 5, enter. So log of 17, enter, divided by log of 5, enter. And here's what I get. 1.760. There we go. Okay, students? All right. Moving on to number 93. Number 93. Okay, we have e to the 2x minus of an e to the x plus 10. Now, I want to say quite a few things to you students, okay? First of all, please don't think these are like terms right here. Remember, if you have x squared plus x to the third, like that, those are unlike terms because one of them is x squared and the other one is x to the third power. Okay, so if you look at your e's here, if there was no exponent here and there was no exponent here and we have e minus 7e, you could put a negative 6e. I have no problem with that, okay? They would be like terms. But because their exponents do not match, one exponent is 2x and the other exponent is x, because of that, then there's no way we can combine these terms. So in the past, what we have done, students, is we have taken the natural log or log base e of both sides. But that's not going to work here. We can't do that because we have three terms here and one term over here. So here's what we're going to do. We're going to rewrite this a little bit. Now watch how I do this, okay? I want this term here to have the power of 2 only. And I'm going to show you why later, okay? So watch. There. Now students, you should recognize that's the exact same thing as this right here. Anytime you have a power raised to a power, you multiply your exponents, and x times 2 is 2x. Now over here, I want to have negative 7 parentheses e to the x. I'm going to show you why I did that in just a second, okay? Now look what I'm going to do right here in the middle of the problem. I'm going to make a statement, okay? I'm going to state that e to the x equals x. And I can do that, students. I can do that as long as I go back and back substitute x, or excuse me, I can do that as long as I go back and back substitute e to the x in for x. So e to the x equals x. So where e to the x is, I'm going to put an x. Minus 7. And then next, notice I have e to the x. So where e to the x is, I'm going to put an x. Now look what I have. I have a quadratic equation. And I can factor this. Think about it, students. What two numbers multiply together give me 10? When added together give me negative 7. That's going to be a negative 5 and a negative 2. When I add those two numbers together, I get positive 10. And when I combine them, I get negative 7. So I'm going to put x minus 5, x minus 2 equals 0. Okay? Now, think what I do next here, guys. Remember, I've got to take each equation, or each parentheses, and set each parentheses equal to 0, okay? Like this. Now, remember, I have to go back now and back substitute e to the x in for x. So right here, students, I have an x. I'm going to put e to the x. And right here I have an x. So e to the x minus 2. So I have two equations to solve. Let's start with this one first. E to the x equals 5, okay? Bring the 5 over and make it a positive 5. Now next, the base of my unknown is e. So I'm going to take log base e of both sides. Bring down your 5, bring down your e to the x. Over here, your base, when your bases match your base, your answer is your exponent. And log base e is the same thing as the natural log of 5. Now with my calculator, I'm going to type in natural log of 5. After I turn my calculator on, that's always a good thing to do, 1.61. Okay, so there's one answer, okay? Not too bad, pretty cool. let's get some space here to work with. There we go. Okay, now bring your -2 over and make it a +2. Okay, the base of my unknown is e, so we take the log base e of both sides. Over here, your base matches your base, so you're left with the exponent. Log base e is a natural log. With my calculator, I'm going to type in natural log of 2, and we will get 0.69 for an answer. Okay, 0.69. So x equals 0.69. And there we go. Okay, so probably out of all 8 of these problems here, I would say that this one here was probably the most difficult. But make sure you know how to do all of these problems, okay? Alright, moving on to number 101. Okay, we're going to solve some logarithmic equations. So here we go, students. Let's go ahead and solve some logarithmic equations. Number 101, natural log of 3x equals 8.2. Now, students, here's what we're going to do, okay? Look, anytime you have a logarithm on one side by itself, write the equation exponentially, okay? Now, natural log of 3x really means log base e, okay? So we're going to write this exponentially. So we would have 3x equals e to the 8.2, okay? Now divide both sides by 3, and x equals e to the 8.2 divided by 3. So quickly, grabbing my calculator, I'm going to type in e to the 8.2, enter, divided by 3, enter, and I'm going to get 1213.65. Now, students, listen to me carefully, okay? Remember, anytime you solve a logarithmic equation, you have to check your answer and make sure you have a positive argument. So if I put a positive 1213 in for x right here, and take 3 times that number, will I have a positive argument? And yes, I will. So this answer does work, okay? It does check. So moving on. Number 103. Okay, now students, on 103, it looks like this too. Natural log of 4x equals 15. Okay, now, first of all, notice I have no logarithms over here. I have one logarithm over here. So the first thing I want to do is get this logarithm here all by itself. So I'm going to divide by 2, these cancel, and I'm left with natural log of 4x equals 15 over 2, or 7.5, okay? Now, also next, remember, I want to write this logarithmic equation exponentially. So this would be natural log is really log base e. So I would have 4x equals e to the 7.5. Okay? Now divide both sides by 4. And my answer would be x equals e to the 7.5 divided by 4. Okay, let me grab my calculator real quick here and see what we come up with, okay? E to the 7.5, enter, divided by 4, enter, 452. Rounded, of course. Now check that answer in your original equation. If you put 452 right here for x, do you have a positive argument? Well, yes, you do, definitely. So this answer is good. Okay, number 105. Notice on 105 we have no logarithms over here, and we have 2 logarithms over here, okay? So we're going to take this left side right over here, and we're going to have to simplify it down into 1 logarithm, okay? So here we go. We have 2 logarithms with the same base e and base e, subtracting. So we know what that means. That means we can write natural log, and then put x over 3 equals 2. So what I did there, students, is I took 2 logarithms right here, okay? And I condense them down into one logarithm. Now, after I've done that, next I want to write this logarithmic equation exponentially, okay? So really, natural log is the same thing as log base e, okay? So exponentially would look like this. X over 3 equals e squared. Now, in order to get x by itself, we're going to multiply both sides by 3. So multiply the left side by 3, we're left with x. Multiply the right side by 3, and we're left with this. So using a calculator, my answer would be 3e to the second power, which would give me 22.17 for an answer. 22.17. Okay, now go to your original equation. Does this answer give us a negative argument anywhere? And no, it does not. If I put 22.17 right here for x, I would then have a positive argument, which is totally fine, okay? So the answer is 22.17. Alright, moving on to 107. Here we go. Now students, look please. I have one logarithm on this side, no logarithm over here. So really, I'm ready to go ahead and write this exponentially, okay? So I'm going to do that right now. So this is base e. So I would have the square root of x plus 1 equals e squared, okay? Now students, remember, anytime that you want to get rid of a square root, you have to square it, okay? But if I'm going to square this side here like this, then I have to square this side over here also, okay? So I square the square root right here. So when you square a square root, you're left with just the radicand here, x plus 1. And over here, when you have e squared raised to the second power, you multiply these two numbers here. And if you multiply them together, you will get e to the fourth power, okay? Now, in order to get x by itself, you will bring the 1 over and make the 1 a negative 1. So x equals e to the fourth minus 1, okay? Let me grab my calculator here real quick. And I will type in e to the fourth minus 1. And I will get this right here for my answer. X equals 53.598. Now students, let's check that answer and see if it works over here. First of all, you can never take the square root of a negative number, so if I put 53 in for x and add 1 to it, I will have a positive radicand. So everything does look good over here, okay? All right, moving on to number 109. Let's give some space here for number 109. Let's move this up here. Kind of out of the way here. Move this up here, out of the way. And here we go, number 109. Okay, here we go. Now students, first of all, the first thing I want you to see is this. Notice I have logarithms on both sides of the equation, so my goal is to do this. My goal is to get one logarithm over here and one logarithm over here, and then when I do that, I can just cancel out the logarithms. Okay, I'll show you what I mean when we get there. Okay, so on this side here, over here, notice I have only one logarithm, and that's good. So I'm gonna leave that alone. Okay, I'm gonna totally leave that alone. So log base 10 of x minus 1. Now, over here on the right side, I have two logarithms. They both have the same base, and they're being subtracting. Okay, so we should know what to do. I can condense those two logarithms down into one logarithm like this. So log base 10 of x minus 2 divided by x plus 2. There we go. Now look what I can do, guys. When I have one logarithm over here and one logarithm over here, no number here, no number here, I can do this. I can cross the logarithms off and just set the arguments equal to each other. So now I have this. X minus 1 equals x minus 2 over x plus 2. Now, the best thing to do here is to get rid of this fraction right here. And I'm going to do that by multiplying this side here by x plus 2, my denominator. But if I multiply one side by x plus 2, I must multiply the other side by x plus 2. So I'm going to multiply both sides by x plus 2. Now here's why I did that. Look over here. These will cancel. Pretend this is over 1. These will cancel, leaving me with x minus 2. Over here I will have this. X times 1, 2 times x, 2 times 1. X squared plus x minus 2. Okay, so there we go. Now students, the first thing I notice here is I have a quadratic equation. So what I want to do is get one side equal to 0. So bring your x over here, make it a negative x. Bring your negative 2 over, make it a positive 2. And you're left with, look at this, x squared equals 0. So that's pretty simple. Just take the square root of x squared. Take the square root of this side. The square root of x squared is x, and the square root of 0 is 0. So there's your answer. Hopefully, okay? But it doesn't work, guys. Look. The reason it doesn't work, if you put 0 in for x right here, 0 minus 1 is negative 1, so you're taking the logarithm of a negative number, and you cannot do that. So, if this answer here fails in just one argument, then you have to say that it does not work at all. So, the only answer we have that we came up with is 0, but 0 doesn't work. So the answer is no solution. Okay? No solution. There we go. Moving on to number 111. Alright, now notice here, students, we have one logarithm on one side, and there's no number here to the left. So we're going to go ahead and write this exponentially. So 1 minus x equals 3 to the negative 1. Okay? Now 3 to the negative 1 is 1/3. Now, students, if you don't know where I got that, then feel free to take your calculator and type in 3 arrow negative 1, and you will get out 0.333 repeating, okay, which is 1/3. Now next, bring your 1 over and make it a negative 1. So we're left with negative x equals negative 2/3, okay? Now divide both sides by a negative 1. Like this, and you get a positive 2/3. Now that might be your answer, it might not be your answer. Let's see, okay? Come up here, and where the x is, we're going to put 2/3. 1 minus 2/3 is 1/3, so we do have a positive argument. So yes, this answer does work. So the answer is 2/3, and I'm checking it now in the back of the book, and yes, that is the correct answer. Okay, 117. Okay, first of all, students, notice that we are dealing with compounding continuously. So my formula is this right here, number 2. This is my beginning amount right here, and here's my interest rate. Notice we're looking for time. How long will it take the money to triple? So this is very simple, guys. My starting amount is this. I'm going to take that and I'm going to triple it real quick over here off to the side. So my ending amount should be 22,650. Okay. Now I'm looking for time. Here's E. My rate is 0.0725 t. Now students, we really should know what to do. We just solved a bunch of these earlier. Okay? Right over here, we had exponential equations. E to a certain unknown. It's the same thing here. We have e to an unknown. First thing you do is divide both sides by 75/50, okay? So that you get e all by itself. You're left with 3 equals e to the 0.0725t. Now, here's my unknown. Here's the base of my unknown. The base of my unknown is e, so I'm going to take log base e of both sides. Log base e of 3. Log base e of this whole side here. Okay, now whenever your base matches your base, cross all that off, and you're left with your exponent, which is 0.0725t. Okay? Log base e of 3 is natural log of 3. Now students, watch this carefully next. I'm going to divide both sides by 0.0725. Okay, so here we go. Natural log of 3. Enter divided by 0.0725. We'll get this from my answer. My answer is 15.2. So it's going to take me approximately 15 years, a little more than 15 years, okay? Let me check the answer in the back of the book real quick. And we are good. Moving on. Okay, number 125. The population of Baltimore, Maryland for years. For certain selected years can be modeled by this model right here, where t equals 0 represents 1970. According to this model, when with a population reach 600,000. So for P right here, I'm going to put 600,000. Okay. There we go. Now, let's divide both sides by this. Cancel here, and you're left with e to the negative 0.011t. Okay, let's divide these out. Grab my calculator here, 600,000 divided by 895,397 gives you I'm gonna write a really good portion of this. 0.67000938. Okay, there we go. Now let's continue on. So obviously, students, I have the base. The base of my unknown is e, so I'm going to take log base e of both sides. Okay, over here on the right side, whenever the base matches the base, everything's gone except the exponent. Over here, natural log of this number here. I'm going to type that into my calculator. So natural log would give me this right here. Negative 0.003375. And then divided by 0.0 negative 0.011. Would give me 36.4. So, now be careful, guys, okay? It says when will the population reach 600,000? Now, if it's saying when, think about this. 0 equals 1970, right? Right here. So add 30. 30 would equal 2,000. So add 6 more years. 36 would equal 2006. So sometime during the year of 2006, the population population will reach, of Baltimore, Maryland, will reach 600,000. Okay, let me check the back of the book real quick, make sure we're correct on that, and we're going to move on. Okay, well, they're actually saying 2007, and I would argue with that a little bit, but either way, that's good enough. So, okay, moving on to 127. Now, what is the interest rate? Okay, it's compounded continuously. There's my formula. A deposit of 10,000 is made, so for P, I'm going to put 10,000. The balance will double in 5 years, so double that. That means I'll have 20,000 over here, and it's going to take 5 years. So R times 5, 5 for T. And we're solving for R. Well, students, we've done this over and over. Here's my unknown. Here's the base of my unknown. I want to get this all by itself. So I'm going to divide both sides by 10,000. These cancel, leaving me with e to the R5 is 5R. Over here I'll have 2. Okay, now the base of my unknown is e, so I'm going to take log base e of both sides. So log base e of 2 equals log base e of e to the 5R. There we go. Now on the right side, whenever your base matches your base, you're left with the exponent. And over here, log base e means natural log of 2. Okay, so continuing on, divide both sides by 5. Natural log of 2 divided by 5 equals R. So here we go. Natural log of 2, enter, divided by 5, enter. 0.139. And there's the interest rate. So really, you should write it like this: 13.9%. Move the decimal 2 places, okay? Let's take a look at that. It's number 127, and that is correct, yes. Moving on to number whatever. 129. Okay, we're gonna write the equation. We're going to write the exponential equation model that models the situation here. So we have 2 unknowns. In order to write the exponential model, we have to find A and we have to find B, okay? So in order to do that, I'm going to start off with this ordered pair right here, okay? So where Y is, I'm going to put 2, and where X is, I'm going to put 0. So A, E, B times 0. Now, B times 0 is 0, so 2 equals A, E to the 0. Now, anything to the 0 power is 1, so 2 equals A, E to the 0 power becomes 1. A times 1 is A. So look at that. Just like that, I solved for A. Okay? Good. Booyah. Done there. Okay? Now, let's pull this up here. So I found A. Now, let's take our model again. And now let's use this ordered pair. Plus, we know what A is too, so we can put 2 in for A. So here's my Y. I'm going to put a 3 equals, here's my A. I'm going to put a 2. Then my E. Then my B. And then for X, I'm going to put 4. Look what I've got. I've got a simple exponential equation. Here's my unknown. Here's my base. So get this whole thing all by itself. So here we go. Divide both sides by 2. And now what is the base of your unknown? E. So we're going to take log base E of both sides. On the right side, whenever your base matches your base, you're left with the exponent. Over here, log base E is a natural log of 3/2. Now divide both sides by 4, and you'll have this: natural log of 3/2 divided by 4 equals B. Okay, so here we go. Natural log of 3/2, enter, divided by 4, enter. And here's B. B is 0.1014. So guys, look. I know what A is. I know what B is. So I'm ready now to write my exponential equation. Here's my model right here. Here's my model. Y equals AE to the BX. So where my A is, I'm going to put 2. And where my B is, I'm going to put 0.1014. And then put my X. There, we did it. We wrote the exponential model that models this situation, okay? Let me take a look at 129, make sure we got it right, and yes, we got it right. Okay, finally, last but not least here, number 133. Here we go. The relationship between the number of decibels B and the intensity of a sound I in watts per square centimeter is given by this equation right here, okay? Determine the intensity of a sound in watts per square centimeter if the decibel level is 125. So look up here, decibels is B and the intensity of sound is I. Well, I am looking to find the intensity of the sound, so I'm looking for I, because it says this right here. So I'm looking for I when I'm given decibel level 125. And this is my decibel level right here. So where B is, I'm going to put 125 equals 10 log base 10 of I over 10 to the negative 16. Now students, look, what I have here is a logarithmic equation. And here's what I've taught you to do. I have taught you that whenever you have one logarithm on one side, get the logarithm all by itself. So we don't want this 10 right here, so we're going to divide both sides by 10. And now I have this 12.5 equals log base 10 of this. Now what I've taught you to do after you have one logarithm on one side isolated, write it exponentially. So here we go. If I write this exponentially, I will have this 10 to the 12.5 power equals I over 10 to the negative 16. Now students, if you want to get I by itself, just simply multiply both sides by 10 to the negative 16. So if I multiply this side by 10 to the negative 16, I would have 10 to the 12.5 times 10 to the negative 16. And if I multiply this side over here by 10 to the negative 16, I'm left with I. So now you know what I equals. I equals this. But you've got to type that in your calculator. So here we go. Let me clear my screen here. 10 to the 12.5. Enter times 10 to the negative 16 power. Enter, and here's what you get. You get 0.00316 rounded. Now, more than likely, your calculator said this. Your calculator probably said 3.16227766 E. No, not E like that, sorry. E to the negative 4. Guys, all that means is scientific notation. 3.16 times 10 to the negative 4, which means move the decimal 4 places this way. 1, 2, 3, 4. Thus you get 0.000316. Okay? Alright, I hope this homework help video has been a help to you guys. If you have any questions, don't hesitate to call or email.